Have you ever wondered what causes a shooting star? It's a question that has sparked curiosity and awe in countless minds throughout history. The night sky, a vast canvas of twinkling lights, has always been a source of fascination and mystery. And among its many wonders, few are as captivating as the fleeting brilliance of a shooting star. In different cultures and times, shooting stars have been seen as omens, wishes, or even messages from the divine. Some believe them to be the souls of the departed, blazing across the heavens. Others saw them as celestial beings, streaking across the sky in a display of ethereal beauty. Such beliefs and myths have imbued shooting stars with a sense of magic and wonder. Yet the true nature of these celestial phenomena is far more rooted in science than in superstition. They are not stars falling or shooting across the sky as the name suggests. But what if I told you these streaks of light are not stars at all? Intriguing, isn't it? So if they're not stars, what exactly are these mysterious flashes of light we see in the night sky? Well, hold on to your telescopes, folks, because the answer may surprise you. These so-called shooting stars aren't stars at all. In fact, they're meteors, but let's break that down a bit, shall we? Meteors are tiny particles from space that enter Earth's atmosphere. They're like space's version of dust bunnies, but these are no ordinary dust bunnies. These particles are traveling at high speeds, up to 45,000 miles per hour to be precise. It's this intense speed that causes them to heat up, creating a streak of light across the night sky, turning them from invisible particles into the dazzling display we call shooting stars. But where do these particles come from, you might ask? Great question. Most of these particles are the remnants of comets and asteroids. You see, comets and asteroids are like the messy eaters of our solar system. As they travel around, they leave behind a trail of debris. And it's this debris that becomes our shooting stars. Comets are essentially dirty snowballs made up of ice and rock. When they get close to the sun, the ice starts to vaporize, releasing dust and rock. These particles continue along the comet's path, creating a debris trail. On the other hand, asteroids are made up of rock and metal. They occasionally collide with each other, scattering fragments into space. These fragments can eventually find their way into Earth's atmosphere, becoming our shooting stars. So, in a nutshell, these shooting stars are merely space debris burning up as they race through our atmosphere. They're not stars shooting across the sky, but tiny particles from comets and asteroids, putting on a spectacular light show for all of us to enjoy. It's one of the many ways the universe reminds us of its vastness and our connection to the cosmos. Now you might be wondering, how does a tiny particle create such a brilliant streak of light? Well, that's exactly where the fascinating science behind the streak comes into play. Let's take a journey through the cosmos to understand this better. Meteors, commonly known as shooting stars, are essentially small particles from space that enter the Earth's atmosphere at incredibly high speeds. Picture this, a particle, no bigger than a grain of sand, racing through space at speeds of up to 70,000 miles per hour. That's nearly 100 times the speed of sound. At such tremendous velocities, these particles encounter the Earth's atmosphere, which acts like a wall of resistance. The particles begin to rub against the molecules in our atmosphere, creating a great deal of friction. Now you've probably experienced friction in your everyday life, like when you rub your hands together to generate heat. The same principle applies here, but on a much grander scale. This friction generates intense heat, up to 3,000 degrees Celsius, which is nearly half as hot as the surface of the sun. This heat causes the meteor to incandesce, or glow brightly. As it zips through our sky, it leaves behind a streak of glowing gas and vaporized meteor material. This brilliant, fleeting streak of light is what we observe from Earth as a shooting star. Here's a mind-blowing fact. Most of these meteors burn up completely in the Earth's atmosphere before they ever reach the ground. They end their cosmic journey in a fiery blaze of glory, often without leaving a trace. So, the next time you see a streak of light dash across the night sky, remember the science behind the spectacle. You're witnessing the rapid, radiant demise of a space particle, burning up in our atmosphere. Therefore, every shooting star you see is not just a beautiful spectacle but also a testament to the extreme conditions that exist beyond our planet. So each shooting star you see is actually a small fiery demise of a space particle. So, we've demystified the shooting star. But does that make them any less magical? Not at all, my friends. In fact, understanding the science behind these cosmic fireflies only enhances their magic. Think about it. Each shooting star is a tiny piece of cosmic debris, hurtling through our atmosphere at mind-boggling speeds. These particles, often no bigger than a grain of sand, were once part of something much larger. They may have been ejected from an exploding star, or chipped off an asteroid during a violent collision. Now, let's talk about meteor showers. These are the grand fireworks displays of the cosmos when our planet passes through a cluster of these cosmic particles. They're like the universe's way of throwing a party, and we're all invited to the spectacle. The Perseids, the Geminids, the Leonids, each of these showers is a unique event with its own rhythm and character. These showers occur when Earth crosses the path of a comet. Comets are like dirty snowballs of ice and rock. As they approach the sun, they heat up and shed particles that spread along the comet's path. When Earth encounters this debris, voila, we get a meteor shower. But perhaps the most magical part of all this is our place within it. We are tiny inhabitants of a tiny planet, spinning through an almost unimaginably vast universe. And yet, we get to witness these incredible events. We get to look up at the night sky and see the universe speaking to us, in a language of light and motion. It's a humbling reminder, isn't it? We are small, but we are not insignificant. We are part of this grand cosmic dance. So the next time you see a shooting star, take a moment. Think about its journey. Think about your own journey. And marvel at the magic of it all. Remember, each time you see a shooting star, you're witnessing a tiny piece of the universe revealing itself to us in a spectacular way. Isn't that magical?